All right. So function compositions, as I said, was a continuation from yesterday's lesson. What we're going to do, last time we add, subtract, and multiply our functions, which are pretty basic and simple. But a function is something where we could replace the x with anything. For example, let's do number one. For example, if I say f of 2, that means every x gets replaced with a 2. Mariah? I forgot, my fault. I was just reading a book that whole time, thinking, I had something to do. But I was just relaxed. My fault. Yeah, we'll meet Monday. Okay. So f of 2. So if I see f of 2, that means every x becomes a 2. So for example, 5 times 2 plus 7. So if I have a number inside my f, I'm allowed to actually get a number answer because I'm replacing every x with a number. So 5 times 2 is 10. 10 plus 7 is 17. So f of 2 equals 17. So whatever's in the parentheses replaces the x. Another example, g of, let's do -3. Example number 2 here. G of -3, that means every x I see gets replaced with a -3. Now this is x squared, so it's going to be replaced by -3 squared. Keep in mind, if you remember a long time ago, we did substitution with system of equations. It's the same concept. We're substituting the x for something else.
Mr. Tawal, is this just what we did yesterday?
This is the next lesson from yesterday. So now we're going to plug in numbers, and you'll see we'll plug in.
This is all new?
This is new.
Got it.
So -3 squared becomes +9 minus 2. +9 minus 2 equals 7. So g of -3 equals 7. So whatever I put inside the parentheses, I can replace the x with. Whether it's a number, that's fine. Whether it's a number or a actual symbol. For example, number 3, instead of h of x, I'm going to put h of 3y. So if I put 3y here, that means every x in this question replaces with a 3y. So 3 times 3y plus 6. -2, the -2 is from the original g of x over here. That's why it's -2. So I'm looking at the equations over here in order to do all my math. So when I say h of 3y, I replace x with 3y. 3 times x, or now it's 3 times 3y plus 6. 3 times 3y is 9y plus 6. In this situation, 9y and 6 are not like terms, so I'm finished. So it's 3y equals 9y plus 6. Another example of this, number 4. F of x minus 2. That means every x, every x here is going to be able to be replaced with x minus 2. So every x here. So 5 times this whole thing's getting plugged in, x minus 2 plus 7. So instead of replacing just a number, I'm replacing the x with a full expression. So this x becomes x minus 2. Distribute the 5, just like a normal algebra problem, we've solved it, or simplified it at least. 5x times negative 2 times 5 is negative 10 plus 7. Combine like terms, 5x minus 3. So notice I could plug in numbers, symbols, a whole lot of expressions into any of these equations. Before I move on to the full lesson, anyone has any questions? Okay. So I'll recopy the thing here. Let's see if it pastes good.
Mr. Tawal, can you put that back?
Sure. So notice, and I know Carmelo, you joined late, but you'll still get the main lesson if you pay attention.
Wait, Mr. Tawal, didn't we do this yesterday?
What's up?
Didn't we do this yesterday?
What we did was just adding, subtracting, multiplying. Now we're actually plugging in numbers into the f of x, g of x, h of x. And then we'll see what we're going to do with that. And I guess to clarify the question more for everyone's understanding, you could not only just plug in numbers, you could plug in full expressions where you're replacing x with full-on equations. Now, the next page, we're going to practice more of this.
I'm kind of confused.
Go ahead, Alyssa.
Like, what? How did you get h and like 3y? Like, where did you get that from?
Oh, h3y is your problem. So
Okay,
I tell
so now
you.
why do you have?
So then
So
you look at
what was
h
your
of x.
answer?
So you look at the h of x I gave you. So what I give you is these equations right here and the problem. So h3y is the problem. So you look at your equation h of x because the letter's h. So every time you see an x, and all these have one x's, sometimes there's multiple x's, but every time you see an x here, you're going to replace it with whatever is in the parenthesis, in this case 3y. So 3 times, now the x became 3y plus 6. So all I'm doing is substituting. Yeah,
Okay.
so all I'm doing is substituting. All I'm doing is substituting, and what's inside the parentheses tells me what I substitute.
Okay, got it. Thank you.
No problem. I'm going to go to the next page. If you need it later, I'll go back to this. But we'll have a bunch of it.
Can you just wait one more second? On the last one, like on the last line.
Sure. You can just, x and y is the same, like replace. So x is the stand-in for this. So 3y is just another thing. You could plug in anything into it. So if I wrote 3k, then it will be a 3k here. And k or y being a variable means I can't combine like terms. So I just have to stop right there.
Is there a new like title for this?
It's still 3.3, Function Compositions.
Okay, I'm good. You can go.
All right.
Thank you.
And then anyone who joined late, I'll just go back for you guys later. But here's the main meat and potatoes of the lesson. So we just identified that you could plug in numbers, you could plug in expressions. What's interesting, and what is called a composition, is you can plug in full-on other functions. So there's two ways to show that. One is f of h of x. So you could plug in one function into another, and that's what we call a composition. Another way this might be written is f of x, and then there's this hollow circle, not like a zero, it's more like a bullet that's hollow. X, kind of like this, of h of x. These two things mean the same thing, okay? Where you have h of x inside f of x. And I'll explain how to do it. I just want to show you that. So these are the type of questions you can have. So for example, h of x, we know what h of x is, by the way. We know h of x is 3x plus 6. So my first step is I'm going to replace h of x that's inside here with 3x plus 6 because they're both equivalent to each other. So I could substitute whatever's equivalent to each other. Now remember the rule. Anything inside the f of x, I could replace the x with. So now I'm going to substitute 3x plus 6 for every time I see x in the f of x equation. That's 5 times 3x plus 6 plus 7. The black being the original f of x equation, the red is what I'm substituting in. So the new lesson of today is I can substitute functions into other functions, and that's called a composition. But after you do all the substituting, it's back to normal algebra. Let's distribute the 5. So that's 15x plus 30 plus 7. Then let's combine like terms. 15x
Where did
plus
you get 5
37.
from?
Question? 5?
Where'd you get 5 from?
5 is in the original f of x right here. Everything's based off the original equations I give you. Okay. Any other questions? Because 15x plus 37 is as simplified as possible. So this is your answer. This is what f of x composited with h of x. Be a little bit more clear in what do you mean by how did he go in, Mariah? You can just substitute. You can replace things that are equal to each other. So the h of x, I replaced it with 3x plus 6. And then the x inside, I replaced it with 3x plus 6. Okay.
So the final answer is just 15x plus 37.
Final answer is 15x plus 37. Again, the 5 is coming from the 5 in f of x. The x, which I rewrote in red, becomes 3x plus 6, and the plus 7 is just plus 7, which is over here. Let's try another one. Number 2. H of g of x. Okay. So h of g of x means I'm going to first replace this g of x with whatever g of x equals. So my first step is going to write h of whatever my g of x is, x squared minus 2. Now my next step is to see wherever x is and replace it with the x in the original equation, or the h of x equation. So since it's times 3x, it's going to be 3 times what I'm plugging in, x squared minus 2, plus 6. From here, regular algebra, distribute the 3. 3x squared minus 6 plus 6. Combine like terms. -6 plus +6 cancels out. So all you're left is 3x squared. So your answer, that h of g of x, ends up equaling 3x squared. Again, I'll take any questions on this one. Remember, h of g of x could be also written as h with an open bullet point kind of thing of g of x. Those are the same exact thing. I'll move this down. It's just how it exists. Because it's math, I'm allowed to combine it into one problem. Okay. We're going to do one more, and then I'll give you your exit ticket. So this one, what's also interesting is not only I could plug in, when I say I could plug in anything into any equation, I really mean I could plug in anything to any function. So I could do f of x in f of x. So I could plug in itself even. Even if we're plugging in itself, it's still the same process. My first step is to replace the f of x with what f of x equals. In this case, 5x plus 7. So f of x on the inside becomes 5x plus 7. From here, I replace that f of x. I have an x here, and every x I see, I'm going to replace with 5x plus 7. Even if it's a self, I could do that. So what becomes is 5 times the inside part, 5x plus 7, plus 7. And this is called an recursive composition. That's it. It composited itself. And technically, you could do this infinite amount of times, but we'll just do it the one time. Again, the new part of this lesson is just how to substitute things. Let's distribute once again. 5 times 5x is 25x. 5 times 7 is 35 plus 7. Combine like terms. 25x plus 42. So f of x equals 25x plus 42. Remember, it also could be written as f with an open circle, f of x. If you have any questions, you're free to ask. Let's go up this way. Or here, I'll zoom out so everyone can see. Uh-oh. But my thing didn't freeze. Okay, there. Your exit ticket. And I don't know if this is first time, Eliana, you've been on a Zoom class with me. As soon as you privately message me the right answer to the exit ticket, you're free to go because it shows me that you learned the lesson today. What you're going to do is give me h of x. So you guys, you're going to privately message me the answer to h of x. Should write it down so I remember the answer.
Are you doing HX from the previous problem?
Yes, we're still using the same ones each time. Just so it's consistent, so you don't have to keep writing new equations. Okay, so you privately message me your answer. If you get it right, you're free to go. Even if you get it right, you can stay if you have any questions for me.
Mr. Toval, can you scroll up so I can see the equations?
There's equations right here. I moved them, I recopied them down here. So you
Okay, thank you.
no problem. No. Oh, no. Alyssa. Eliana, you got it. You're free to go. Alyssa, when you replace the x disappears. So it's not 3x times 3x plus 6. It's 3 times 3x plus 6. The x disappears because it's getting substituted. Okay?
Wait, what?
You did this.
Oh, so the oh, okay, fine.
This is what you did. What you should have is just a 3 here, okay? Ella, you got it. You're free to go.
Thank you.
No problem, Mariah. Nahum, shouldn't it be x squared? Where do you get an x squared from? It should be 3 times 3x plus 6. Carmela and Sheva, thank you. You're good to go if you want to.
I thought since you're doing two H's, it should you're just multiplying everything, so it's going to be 3 times 3, x and x. You can't do x.
No, you should follow the steps I mentioned in order to do it.
My bad.
That's fine. Alyssa, you're good to go. Have a wonderful day, okay?
Thank you, you too.
No problem. Okay, Nahum and Mariah, let's talk about this. So, Mariah, I want you to tell me, what is this h of x about to become? What is that h of x about to?
Okay. H meant I thought that it meant 3 from the outside of the 3x plus 6, and then the x would say x plus 6. Wait, no. Then it would be 3 again.
Let's one step at a time. One step at a time. What does the h of x here become over here?
H 3x plus no, so that's x.
No, go with your
Or
gut.
the H
3x plus
is-
6.
I don't know
That's right.
what the h is, so that's my issue.
Okay. Next part. We're going to now take the 3x plus 6, and I'm going to plug it into the x right here. This is like another iteration of h of x. Okay? They are the same values, but they're not the same versions of them. One is the bigger version, and one's the smaller version. And one's the
Yeah.
inside.
That's where I'm getting confused.
So it should look like 3 times 3x plus 6 plus 6.
How are you?
How am I doing? So every x I see in the equation, so this x right here, had now become 3x plus 6. No matter what I plug in here, every x becomes what it is. Whether it's a 2, whether it's a 3y, whether it's a dollar sign. No matter what I plug in,
So look,
it will change.
no, that's 3. The h's are both 3, so 3 times 3x plus 6.
Plus 6. H is not just 3x. It's 3x plus 6. The whole kip and caboodle.
I thought h 3. H is 3. The x is x plus 6. No.
When I say h of x, it's the whole equation here. It's the whole unit. You got to include everybody. Don't exclude anybody. Okay?
Oh, I was excluding. Okay.
Okay.
Wait. So h of x means that. Oh, so that equals 3x plus 6.
Mm-hmm.
Right?
Yes.
We know that the h. Then how did we figure out the h's on the outside? That's where I'm confused now. Where did we get?
So
the
this
h's
h you're
on the
talking about?
outside? How do we know that that's 3? Yeah.
Okay.
Outside one.
I see what you're thinking. You think this h just straight transform into a 3. Is that what's looking like?
Yeah.
Okay.
That's a.
When I say h of blank, it's like a instructions. It's like I'm telling you to do this. It's like a recipe. So let's say if I said g of h of x, we're going to do a side problem that doesn't cause this situation. I'm going to replace that h of x with 3x plus 6. I don't look at the g as in a number. I look at g as something I followed the equation for. So in this case, yeah, so in
I'm
this
looking at it
case,
as a number.
yeah, it's not a variable in the
Equation
way
you're
you're
saying.
thinking.
So then how do you, so now that okay. So due to it being not like a variable, that's an equation. So then wouldn't h be again 3x plus 6, 3x plus 6? Oh no, you're saying h is 3, x is x plus 6 on the equation.
So the
H
original
equals
equation is 3,
equals x
I'll put it red, x plus 6. The red x's, or every x, I should say, it's not always going to be red, but the x is the only thing that gets replaced. So that 3 red x is going to become 3x plus 6. The black parts don't change because those are just numbers. If they were x's, they would change, but they're not. Okay. So finish it off for me. 3 times 3x.
9x.
3 times 6.
18.
and 6 plus 8, or this is 6. The 6 doesn't change. And then, can we combine any like terms?
So you're saying it's just 9x plus 18 plus 6?
No, those aren't like terms. What are like terms here?
No, and 6 like terms.
Okay, and that becomes
9x equals 24.
that equals 9x plus 24, okay?
What? Oh,
You're just combining 18 plus 6.
that's your final answer.
That's your final answer. That equals h of x.
Wait, I wrote 9x plus 24. Is that
9x plus 24 is written right here. Unless we have a lag, it's written right there.
No, but like I wrote 9x plus 24. You like described it. I wrote it.
Yeah, it's written on the bottom. Can you see the bottom part of it?
No.
It's right here.
Now you're right.
Then we must be lagging or delayed because I've wrote it a while back, so I'm not sure.
Oh, yeah, now it's right. I see it now. Okay, yeah. Perfect. Yep. It was lagging.
Mhm.
All right. Okay. I'm meeting with you Monday, Mr. Tobal.
Okay, no problem. I won't forget this time. My fault, boss.
Thank you.
No problem. Nahum, Mariah, have a
Thank you,
wonderful
Mr.
day.
Tobal.
Okay?
Have a great day.
You too, guys.